I think I get to transition to our next panel, which is the Digital Transformation Toolbox, and we have the distinguished Ed McClarney of the NASA leadership team for the CIO as a moderator. He's the lead for transformation integration and AI/ML, transformation and data division. Take it away, Mr. Ed.
Thanks very much. Hi, everybody. My name's Ed McClarney. It's really my pleasure to be here today. I'm here on behalf of Ms. Jill Marlowe, who leads digital transformation as an agency-wide initiative for NASA. I was just thinking as I was watching the previous panel that we're going from all kinds of forms of propulsion, to include nuclear propulsion, to what we might call digital propulsion. So if I were smarter, maybe we would have named the panel Digital Propulsion, but I really see digital transformation as something we can all use to add thrust to our work. So, I will give a few kind of introductory context motivations. Once I do a quick intro, then I'll let each of you introduce yourselves, give some comments, and then we'll have a conversation. So we're really glad to have Virgil Hutchinson here with us, Senior Director, Senior Chief of Engineering from Northrop Grumman. Anna Woolley, an Assistant Professor here at University of Alabama in Huntsville. We've got Lee Wilbur, Managing Director at Deloitte, and Ron Kessing, Senior Vice President for Technology and Technology Integration at Leidos. So I wanted to give you all just a few motivations, and then we'll get to the real experts here. So yesterday, listening in, my heart was really pretty warmed by listening to all the different associate administrators for our different missions, saying how that they're acting as one big team, coordinating, getting back to the moon and onto Mars together. And really, my transformation boss, Jill Marlowe, looks at NASA's digital transformation similarly. Everybody can go off and do their own thing and kind of make progress in digital transformation in their own lanes, but you really don't get as much traction and you don't go as far as you could as if you transform together. So we're trying to get back to the moon and onto Mars together. I think we need to transform together truly, not just across NASA, but across all of our NASA communities. One other thing is, as we're trying to make our technical advancements, I really think we can use digital capabilities as an axis of innovation. If you think about it in our lives the last 10, 20 years, the biggest changes that we've seen have been digital advances. So we can either become victims of that trend, or we can use that trend to our advantage. So leverage technologies as an axis of innovation, again, to add thrust to our work. Something else that I really loved hearing yesterday as we were talking about the different missions, both reps within NASA and partners, whether it's different countries or different companies, talking about standards, interfaces, interoperability, shared approaches. That completely makes sense to me from a physical standpoint as well as a digital standpoint. So I would suggest that one of the things that we can do as a community, if we want to transform overall together, is work according to standards, integrate at the edges, at the interfaces, things like that. One thing that's really important, as a kind of a digital transformation evangelist, I realize that it's really important that we balance technology innovation with mission surety. If we're putting a few astronauts on the top end of a rocket, we don't want ChatGPT in there hallucinating command and control signals. So there are a lot of areas in our scientific work that leads to conduct of the missions, and areas in the missions themselves where digital technologies can be integrated. I think we need to leverage digital innovations where we can, while also being smart and safe and intentional about it. The last thing I would tell you is I think you cannot afford to sit on the sidelines of digital transformation and wait for all the dust to settle, because the dust is just not going to settle. So my encouragement to anybody is to start, to learn by doing, and to iterate. So a little bit of motivations and context. I'd like to let each of our panel members introduce themselves. And the first question, so it's introduce yourself and tell a little bit about how you are approaching digital transformation. especially applied to space? Ron, if you'd like to go first. I'm sorry, Virgil, if you'd like to go first.
No problem. So, good afternoon, everybody. My name is Virgil Hutchinson. I'm the Senior Chief Engineering Director at Northrop Grumman. Part of my job currently, and I've been in this role about 18 months, is being over and getting the inside oversight into all technical things that happen around space within the company. It's a large task, and I'll say within the last 18 months, I've been able to see a lot of great things and handle some not so great things. But prior to that role, my job was the Digital Engineering Director for Space at Northrop Grumman. That was a great opportunity because maybe some of you know, maybe some of you don't. Northrop Grumman had a corporate-wide push a few years ago that we as a company will digitally transform. That was an edict from our CEO, Kathy Warden, and I was one of the folks that got selected to lead that charge from an engineering and technology standpoint. And so, to your point, Ed, one of the focus I had was how can we actually use this more in space? Because I will say the approaches that we have within Northrop Grumman, besides this corporate-wide effort, which you can say is just a bunch of words, but it's actually how can we get this involved on our actual programs? That to me is a key thing, is how you actually can show that implementation and move it forward. But I will say we've seen evidence of that for our Cygnus missions, which is our spacecraft that delivers cargo to the International Space Station. One of the key things we've done from day one is leverage integrated capabilities to tie the models together and use that to actually determine how we fly the mission, how we load the propellant onto the vehicle, how we can determine what cargo we can carry, the power loads, all of that stuff was integrated digitally together and used for every single mission we've done over the last decade or so. So we've actually started using it. But then I think the biggest part of it, and this goes to your point again, Ed, about collaboration, is one of the approaches we're having is to get out there and connect and share our digital transformation with our customers. I actually had the pleasure of sitting with Jill Marlowe and her staff probably a couple times within the last year to say, here's our digital transformation roadmap, and we started the activity of how can we align better with NASA, with the overall agency digital transformation roadmap, but also with specific centers and what they're looking to do. And so one of the things we've been doing is, along with sharing, is looking to explore those opportunities. So, for instance, a good example is with Goddard Space Flight Center. We actually started having a few quarterly meetings where we sit with them, talk about some of the activities they're doing, actually started identifying areas where we could both provide digitally transformed solutions today to help each other's task. And so the idea is to leverage that as an opportunity to partner up, not just for our own individual works, but what things we can do together. So that's the start of the approach, and I'll just say that I'm looking forward to this conversation. I've been getting ready for it all week, but I'm looking forward to talk with my colleagues here, and then entertain any questions we have aboard. Thanks.
That's wonderful, and it also highlights, again, yesterday and for the past, who knows, decade, we've been all hearing about the need for us to work with far more partners, not just a few. And so having those discussions, doing those integrations, working together, not only on the mission stuff, but on the supporting things,
right,
like digital capabilities, absolutely makes sense. Glad you're leaning into that, Virgil. Anna, would you introduce yourself and tell us a little about your thoughts on digital transformation?
Yes, sir. Hello, everybody. My name is Anna Woolley. I'm an assistant professor here at UAH in the Industrial and Systems Engineering Department. I just recently joined 2 months ago, as I just also finished my PhD 2 months ago. So I'm here to add to this conversation on digital transformation more towards on the digital twin side, which is where my research focuses on. And I wanted to share with you guys what I found while reading and studying digital twins for the last 5 years now during my PhD, is that, as I'm sure all of you have heard of digital twin, and if not, you will at some point. And it's very confusing because digital twin is a virtual replica if you just summarize it as it is just a virtual replication of a physical part, physical entity, a physical system, but is isn't that just also a simulation? A simulation is also a virtual representation of a physical system. A CAD file is a virtual representation of a physical system. So what makes it different? What is digital twin? What are the capabilities that make it a digital twin compared to the other technologies that already exist? So I particularly looked into simulations in digital twins and contrasting their capabilities, and try to add to the academia side and the industry side some more knowledge on how to differentiate those two technologies, and try to, because as I was reading papers and trying to see if people were actually doing digital twin or simulation, I found that it is evident, like I think it was 33% of the ones that I read were not a digital twin, were just some form of simulation. And I will share with all the other questions that we're going to have a little bit of what I found in my research. So I think that's all I had to say.
Great, Anna, and it's great for all of us to help demystify some of the terminology and to also use terminology kind of correctly or in an authoritative manner. So sounds like you'll be able to help us with that. Great. So Lee, your turn, sir.
Thank you. First of all, I'd like to say all the panelists were so excited to have Anna on the panel, because in our prep session, we actually wanted to just talk more about digital twins and exactly some of the points that she was raising. So very, very excited to see how the conversation goes. Again, my name is Lee Wilbur. I'm a managing director at Deloitte. In my 40-year career across aerospace and defense, I've had the chance to work across the Department of Defense, the intelligence community, and with NASA. Actually started back in the 80s. After a few years doing advanced aircraft development, moved into the space side of the business. And then after putting up satellites for a few years, I thought it might be more fun to shoot them down. So I moved into the anti-satellite and did that work in the late 80s and early 90s. And from there, it was a fairly easy transition over to ballistic missile defense. I was the chief system engineer on the National Missile Defense Program in the late 90s and early 2000s. And then had a chance to work across a range of again, DoD, intelligence community programs, and worked actually a number of efforts with NASA. But at Deloitte, my focus has really been on digital engineering and how to take digital transformation into the engineering and really the entire product development life cycle. So again, I see a lot of parallels with the prior panel, because in my mind, digital transformation, digital engineering is all about going faster. I'm a firm believer that time is money, and if we can do something faster, it's generally more efficient, and we can save money along the way. And I think that's something that just resonates with all of us, whether we're in government, whether we're in industry, to be able to move and demonstrate, develop new capabilities faster and more efficiently. So at Deloitte, we've encapsulated a lot of our thinking around digital transformation and digital engineering under what we call a model-based enterprise construct, and really focusing on model-based approaches to do everything from requirements definition to product design and development, even looking at manufacturing and ultimately operations and sustainment support, all using an integrated set of models. And a lot of folks want to say, well, then the key here is having the right set of tools. And the latest version of a Cameo or a Team Center, or utilizing virtual reality to simulate manufacturing and things like that. And again, tools have progressed dramatically over the last several decades. But we find that the bigger inhibitor or bigger challenge in terms of truly moving forward is cultural. That folks want to take in new tools, but essentially execute the same processes that they've been doing for the last 10, 20, you name it, 30 years. And so you really need to take a step back and ask yourselves, how would I do this differently if I had an integrated model that all the stakeholders could interact with, access to an authoritative source of data. I could start to look at doing not only software in an agile type process, but hardware designs in the agile process. You start to see where data becomes a much more central element of a design. So it's not just hardware and software, but it's hardware, software, it's data. It's even modeling the operations of a complex system. And when you can do the complex interactions across those 4 dimensions, you can really start to achieve some efficiencies and move faster. I'll give some specific examples later in our discussion, but that's really where our focus is at and where we're helping both government and industry organizations realize the potential benefits of digital engineering and model-based approaches.
Great, Lee. Ron, your ball.
All right. Hi, Ron Keesing from Leidos, where I serve as our Senior Vice President for Technology Integration. So I come to this panel as a longtime expert in AI. I've been in the field of AI for over 30 years now. It's kind of fun. Anytime I talk to NASA, it feels a bit like coming home because I actually started my AI career building autonomous spacecraft for NASA back in the 90s. And it's actually sort of interesting to reflect on that because it's really, in some ways, the beginning of a digital transformation journey for NASA way back then. So my role today is overseeing AI, cybersecurity, software, and digital modernization practices that span the entirety of all of Leidos's businesses. And so that includes our national security work, defense work, intelligence community, but also work with civilian agencies and also in the healthcare domain. And in all those domains, there are a set of common problems that we see and common challenges that we see every organization struggling with around digital transformation and also seeking to take advantage of the opportunities they see in digital transformation. So one of the exciting parts about my role is the opportunity to help cross-fertilize as we see best lessons, as we see what works, what we see happening over in DoD and the digital transformations that we lead there. How can we bring those lessons over to help NASA with digital transformation as well? For example, one of the largest digital transformations that we're leading is for the U.S. Navy. Their onshore networks are managed under a very large program called NGEN SMIT. And these are massive networks that are incredibly expensive for the Navy to operate. So one of the challenges is how do we guide that digital transformation? There are some common lessons. Lee, you mentioned the degree to which it's not just a technology challenge. I couldn't agree more. In fact, I would say, digital transformation, most of it really isn't rocket science. And I know that because I listened to the last panel. It's mostly actually an organizational change management challenge more than anything else. So that's the first really big lesson, that we see commonly across many organizations as we guide the digital transformation journey. I think the second big challenge that Anna sort of hit on is defining clearly what your goals are if you're going to create digital models, digital twins of parts of your systems, being really clear on what your goal is. Is your goal to go faster? Is your goal to unleash new capabilities? Having a real clear vision of that is critical because the truth is you can make the building of digital representations of your systems arbitrarily complex and expensive. And so understanding what the right point at which to model, what's the right resolution for representing your system so you actually can generate the value you're aiming for is really critical. I think the third big lesson that we see is it's incredibly important to have kind of a guiding North Star purpose to that transformation. For example, in our work with the Navy, that guiding North Star has been about driving user experience, right? The user experience of users on that network has historically been not what it should be. And so when we took over that job, the very first thing we did in talking to customers, talking to all the stakeholders, was identify that user experience. What's the latency for users on that network? What's the general capability delivery and all the different time intervals? That turned out to be their North Star for digital transformation, and it guides all of our work moving forward. And I encourage organizations, as they think about digital transformation journeys, to really think through what is the North Star guiding your digital transformation journey.
I love it. It's great to hear the thread of culture in there. Sometimes in our NASA digital transformation discussions, we joke that culture eats technology for breakfast. So may have heard that in other places. Also, I think it's a really important point that you don't have to have extremely high fidelity across everything you might be doing for a given digital twin, because what you really need is the most effective way of modeling that and computing it and representing the system to get the answers that you're thinking of. So I think that hits on things that you're both saying, Lee and Ron. So next question. This is I think some of the things that you've been doing, Ron, have been working on scaling digital transformation with some of your customers and partners. So what if we start at that end and come back this way with approaches you would see to working to scale digital transformation? And that might be, for some of us, we might be doing it in pockets, we might be doing prototypes. So how do you go from prototype to pilot to production to scaling, organization-wide? Thoughts on that, and starting at that end.
Well, you've given about 50 different dimensions there. Let me talk about it again because of my cross-organizational role. I tend to focus on how we scale horizontally. How do we take the common patterns we see across many organizations and use that to fuel effective digital transformation? One of the patterns that we see again and again across many, many organizations is the common insight that capability in, this kind of comes back, I think, to the point raised earlier that, the advances over the last 20 years have primarily been in the digital domain. And so what we see is new capability tends to be delivered in systems not at the hardware level, although occasionally we see dramatic advances in propulsion. They're rather at the digital level, and it's really that integration, I would say, of, as was Lee mentioned, it's data and software. I would also argue now it's AI as part of that critical layer of integration as well, and then integrating that all within a comprehensive security framework that actually delivers the assurance necessary that you can actually put all this into the field. And so building out what we kind of talk about that as a common mission ecosystem now within Leidos, that we see this again and again across so many of our customers. How do we actually accelerate the process of bringing together data, producing software that leverages that data, and AI that makes use of that data into integrated solutions that are, that ultimately users can consume to deliver new mission capability? Because every customer faces the same problem, that they're having to work with a series of legacy systems. They've got legacy hardware, they've got new hardware, but all of this comes together fundamentally at that level of data, software, and AI. And so if we can kind of master that pattern and help organizations master that pattern, that's where the real capability benefits of digital transformation typically get realized.
It's kind of almost practicing the art of transforming and becoming good at it. All right. Yeah, cool. Great. Lee, your thoughts?
Ron, I resonate so much with what you're saying. I want to maybe just pull on a couple threads a little bit more. So one of the real benefits that we see is digital transformation, again, model-based approaches, being able to create this almost seamless tie from mission need, mission requirements, to product requirements, to product design, to manufacturing, to then ultimate operations and sustainment. I think especially on government programs, it's really hard for one organization to try to really move out on their own. If I could implore this group, one thing to think around is how can we get better coordination between government and industry on how to really implement and move digital transformation, digital engineering, digital twin, AI forward. We've seen multiple occasions where, a company may want to move in a more digital direction, and certainly not at NASA, but other government organizations will continue to ask for, let's kill 100 trees, let's go through a gross of red pens and do a PDR. And, spend 30 days, going through a bunch of just documents or artifacts. Whereas if you think about evolving the design in a model-based approach, you can, again, kind of step back and rethink, how do I do a design review? We actually did a program with the Navy over the last couple years where we took a design and went through a PDR and a CDR and conducted those design reviews solely from a SysML model. And we actually brought the government along that process. We had bi-weekly meetings to walk them through the evolving model. Along the way, they became familiar with how to navigate through the model, find the information they were interested in. The design review, the PDR still had a little back and forth, and they wanted to see things on paper. But by the time we got to the CDR, in one day, we completed and they certified a completed CDR, and everything was done from the model. So they were asking questions. They had their laptops open, drilling down through the model, looking for information, asking questions. We were able to respond through the model. So getting that, again, in this case, model-based type thinking, but getting government and industry, and especially on the complex programs that NASA runs, where it's not just one industry, you probably have 3 or 4 or even more industry partners that are all developing pieces and parts of the system. So how do you ensure they're all working together from a common baseline, right? A problem all of us have had to deal with. And again, having that single authoritative, source where the stakeholders can go and understand what is the current baseline, what are the variants then or changes that are coming through, regardless of which stakeholder community that's coming from, and that we're able to assess, are those having impacts on other parts of the system. So again, that type of efficiency, and then drawing that through the whole product life cycle. So when I'm doing, post-deployment changes, and I want to assess, what's the ripple effect back through the design and even impact on some of the mission requirements, and being able to do that efficiently and very quickly is just a huge benefit that I think all of us, if we could work closer together, get that better coordination, would all really appreciate.
Lee, it sounds like there's a cultural aspect there too. Sounds to me like if you had just come to the PDR and attempted to do it in digital enabled form, you probably would have got kicked out of the room. But it sounds like you had to walk the team through the process of trusting the digital engineering approach so that you could get to that efficiency at the end. You want to comment on that?
It is, and that's kind of when I use the term an agile system development. So not just for software, but again, do these, I almost want to call them scrums, and I don't want to over-rotate because, again, there's differences in hardware design and software design, but bringing people along as that design matures vis-a-vis targeting these major milestones and having the community come together just at those periods of time. So bringing all the stakeholders along at a regular, frequent schedule, and just, again, creates that efficiency. I would offer it builds trust across the organization, so you avoid some of the pitfalls that we often run into when people just come in for the month that you do a CDR and then they go away. So they're just more up to speed. I think a lot of benefit to be realized there.
Great. Anna, what do you think about scaling things and, maybe even just scaling the concept of digital twins or the employment of digital twins?
Yeah, when you're talking about digital twins, I think like Ron mentioned also, and you did too, Ed, you first need to define what do you want to get with this digital version, with this digital twin, because some other tools that already exist might solve your problem. If you're just looking into how this system would behave over time, a simulation model would literally just solve what you're trying to look for. But are you trying to monitor what's going on right now in real time, in real live information coming connected from that system? Do you need that level of capability to just simulate over time some different positions of machines that you're trying to move around in your manufacturing facility? So I think, and that's also what's lacking, I think, is just that education on trying to understand what can we achieve with the digital twin. And I don't think we even know yet completely how to do that. But there's definitely that difference between all these other tools. And when in my research, just looking into simulations and digital twins, I noticed the main difference there is just that live connectivity, you're creating a digital model, digital version of your physical, but it's of one physical. Let's say it's the VIN number of a car, it's not of cars. So with the simulation, you're simulating how cars react, how rockets work. I'm talking about cars because my background is automotive and manufacturing. But you relate to the astronautical because it's manufacturing anyway. So yeah, so it's that live connectivity, a simulation model could be using live information, could be using real-time information, but use it historically. You have input analysis to analyze all this data information and input in your model. A digital twin version needs to have that real-time capability to be able to connect to that physical. And that's all the applications that I see, at least in published papers, is when you already have a physical and you're trying to create that digital version of that digital twin of that physical, and you try to put sensors, all these IoT technologies, all these sensor capabilities to gather all this live information to connect to your virtual, to represent that physical, one physical. But we don't really see, and the digital twin also, a bigger capability is to also bidirectionally connect that data. So it's not only one flow flowing from the physical to the virtual, but also from the virtual to the physical. You want your model to be able to use all this AI and machine learning, all these other capabilities to be able to make decisions for you, whereas the simulation is only using historical data you try to represent. It's still a representation, a high fidelity representation of a physical, but I think the biggest thing to scale it up is at least try to understand it first. Why do you even need to do digital twin? It's that, are you doing that because it's a buzzword and everybody's doing it, or it's you really want to monitor, you really want to define all these requirements and how you're going to measure all these requirements with this digital version, because you're modeling not only how the system behaves, but also that behavior, but also the characteristics about it, how the temperature changes in your machine, or how all these characteristics of it, because it's that physical that you're trying to create, the virtual. And I don't see many applications yet in a paper world, academia world, on when you don't have the physical yet, which is, I think it's very applied to this crowd, when you're trying to come up with all these expensive systems and you want to test it and you want to make sure it will work well. So how do you use that digital twin before you actually have a physical created? And that's a challenge that I'm also researching, so I don't have any answers for that. But because I see a lot of applications after the after the physical is created, but how about before, and how you use that digital twin? What is the goal to help you in a digital transformation to achieve? So, yeah.
Great. So I would say it's sound engineering practice to say, what problem am I trying to solve as step zero for employing a digital twin or anything else, like you said. So.
And I think it's to use any other tool as well. Like, you need to know if that, what is your goal there, and to see if what you're trying to use would help you out with that, so, yeah.
Great, thank you. What about you, Virgil? Approaches to scaling transformation?
Yeah, and I would say that Ron, Lee, and Anna have, you all have given great answers, and I don't want to repeat them because everything you said, I was like, oh, that was my answer. And there are a lot of things I could go on and on about. Trust me, this is something I love to talk about. But I'll say two things. One is, and this kind of goes to what you said Ed, a little earlier, the big thing is culture. And we always say back where I'm at in spaces, culture eats strategy for breakfast. Because you can make all these plans and everything for how you want to implement it and how you want to scale it. But if you don't allow that culture to, explore these different options, be able to understand how to adapt to it, and then eventually after they adapt their things, adopt it for themselves and take ownership of it, and then eventually it becomes established as your baseline. Unless you allow that to happen, it's all for naught. So culture is number one. The other big thing is, I would say, and this sounds kind of weird, but it's recognition. Being able to recognize where you see the digital transformation happening, be able to recognize either when you're starting it, when you're ending it, and recognizing where it exists in other places that you could possibly use it. And I think that recognition is so big because I've seen, even within Northrop and in other companies as well that we partner with, that there's always a time where they're continuously transforming. And I'm like, well, why are you transforming? What was your problem? Did you solve it yet? Did you recognize that you solved it? Or are you continuing to sharpen that pencil until it's a little nub? So recognition is important. And I would say, Anna, you said something that just triggered something within me. So at least within space, and I would say within Northrop Grumman, we've leveraged a lot of the progress we've made in space for our digital transformation. Because if you think of our space missions that we do, we only get one shot to launch it. We got to do everything from an analysis, integration, testing on the ground virtually to simulate that environment. And then I would say the biggest teacher, at least from my experience for a digital transformation, digital engineering, is an anomaly. Nothing teaches you more than having your bird in orbit, and all of a sudden you're not getting the telemetry like you expect. All of a sudden things are not working like they expect, and you're like, all right, let me see what data I can get from the satellite while I'm waiting on, before this pass ends for information. Then all of a sudden you're sitting there like, all right, let's use our real world sim to simulate what happened and be able to reverse engineer the problem. And then I know for us, we call it a flat set, but basically it's all of your critical hardware sitting in a lab where you can take that back there and say, all right, this is the problem. Can I replicate it on the hardware? All right, we got to replicate it. We can now figure out a software to fix it. We simulate that software with our twin. We upload it into the bird in orbit. Now everything's right with the world. And I would say what we've learned at Northrop is there are a lot of the areas in our air domain, in our maritime domain, in our cyber domain, where we've been able to start leveraging a lot of what we learned from our space missions to help them. I mean, there was one example where on a Navy program, they came to me and said, hey, all those things you guys are doing in space, I want to do that too, because we've received direction that we need to reduce our flight test by 20%. And I was like, how are you simulating all of your subsystems? How are you simulating command and control? And they're like, we don't. We get a pilot to go up there and try it out. And I was like, all right, let's chat, because I don't get the option to do that with a spacecraft. So there are a lot of things of being able to recognize digital, being able to see it in different places, because I will tell you the biggest misnomer that I've seen over the last few years, and I get this a lot from some of my customers, so let's just say in this area, is, yeah, digital transformation, where's that Cameo model? And I'm like, oh, yeah, that's just like one part of the digital ecosystem. What is the problem you're trying to solve? And being able to recognize your problem and recognize solutions that can help you is really how you scale.
Recognizing transformation seems really important to me. Learning from issues or failures, I think you had wrapped in there too. What do you think about either, taking enough risk in simulation or, in the digital areas so that you're failing sometimes, and people talk about failing fast, taking a risk. I'd far more rather we burn a few electrons than blow up a rocket. So can these capabilities help us take more risk from which to refine our physical solutions?
Absolutely. And it's funny because I have this same conversation when we start talking about, well, we got to get another high-powered cluster to do that. And I'm like, yeah, I'd rather spend whatever thousands of dollars to get another cluster to run another million runs than to light that rocket on the pad for a test and possibly blow it up. But it's one of those where we can definitely leverage it. I think it's just getting comfortable with the results. And I think, Anna, you brought up a really good point of understanding the huge, and Ron brought it up as well, understanding the huge amount of historical data that's out there, being able to get models that can access that data, and then finding ways to put that data in the simulation and learn from it. That's where AI and ML come in significantly. But being able to leverage all of that so you feel comfortable with taking that risk.
Awesome, awesome. So
I want
I'd ask.
to- oh, can
go
I
ahead,
add
Anna.
something?
Yeah, go.
Just to the cultural that we're talking about here for the digital transformation being, you have to do it slowly and try to get people involved to be able to make it happen. But I also think it's that education. You're educating your crowd on how to take that digital transformation going on, but we also need to educate the ones that are gonna be there working, so the academia side of it, be able to talk about these in our engineering majors, to have those students to at least know how to talk about it once they get to the workforce and be able to learn, because, you know, you're here to try to learn. You go to school to prove that you can learn. Then you can go to work and be more adaptable to those changes that we have been seeing in digital transformation.
Great. I'd like to go to a couple quick rounds, and these questions are for anybody. We don't necessarily have to go in order, but one question is, as we have some of these emerging technologies, especially where they don't behave in deterministic manner. You know, we've all been reading about ChatGPT or Google Bard making up or hallucinating funny or dangerous answers to queries that we might make. How can we go about, AI specifically, how can we go about trusting, judging the outputs, verifying, validating these kind of technologies? Anybody want to take a whack at that?
People are pointing my way since I said I was the AI guy. Yeah, you know, it's such an interesting comment and concern, right? There's a whole lot of publicity about you know, the risks of using kind of generative AI in open-ended ways. And we see all sorts of customer responses, everything from, you know, some of our customers who want to stand astride the train tracks, you know, saying stop, to those who are leaning forward without really, I think, enough awareness of the risks. I think it's very important moving forward, first of all, that organizations understand how to have a risk-based framework for assessing how they're using AI. That's the first big lesson. There are a lot of very low-risk experiments that you can enable if you kind of set up ways to protect your data and allow people to experiment with AI. We certainly have done that within Leidos, and we've seen employees come up with extraordinarily cool applications of generative AI for kind of demonstration purposes. But when you talk about putting those into real production environments, that's when you need to think about how do you manage these risks. There are techniques to do it. There are very effective ways to manage, for example, risks of hallucination in large language models, but you need to understand how to do that, and there is both an art and a science emerging on how to manage those kinds of risks. I think the second really important thing about risk management and about AI introduction for trust is people tend to think about AI introduction as this kind of all or nothing thing, right? I didn't have any AI, and now I'm just going to hand the system over to AI. And that tends to be a really bad way to introduce AI for a lot of reasons. Tends to be high risk, tends to actually lead to a lot of human resistance, natural human resistance and distrust to technology. So we actually use a structured methodology whenever we can when we introduce AI into new applications of a very gradual and staged introduction of AI in different levels of capability so that humans organically learn to trust AI in lower risk applications. And as both the AI gets better from that human feedback we receive, and as humans kind of understand where they can really trust the AI and where they need to use their own judgment to supplement the AI, you end up with the natural evolution of workflows where humans and machines team together very well, and you can get better results than either humans or AI can produce alone. We see that, for example, we've built out some medical use cases where we do kind of tasking that traditionally humans could only do at about 80% accuracy. We can use AI to drive the process up to about 90% accuracy, but we don't fire all the humans. What we do is team humans and machines together, and we can get to about the 98% accuracy level, taking the best of the judgments that both sides can make.
Excellent advice and observations. Anybody else want to complement that? Okay. I can relate to that even on the auto industry side of things. Over the last probably 6 or 8 years, the auto industry has been worming AI into our new cars gradually, bit by bit by bit, rather than some big bang approach. So to me, I think of a lot of this is we can incrementally grow the capability. We can incrementally grow to verify, validate, test, and trust it. And that takes getting in early, mashing around in the digital transformation solution spaces, and learning as you go. So one of the questions that we've got here is what we would tell anybody, and we can end with that before we do a few audience questions, but what would each of us tell any of our fellow leaders as they think about digital transformation? And my take on that, sorry if I'm taking your answer, my take on that is to start and to learn and to just keep going. So don't sit on the sidelines, start, learn, iterate. What about you? What would you tell any fellow leader if they're thinking about digital transformation, especially if they're going, I don't know about this stuff?
And I would say that the one thing I've told, and this is, I would say, leaders or those who are practitioners, is it's all about understanding. Believe it or not, I've spent the last 4 or 5 months more than I would want to in meetings where we do it all digitally. And it's great, but it's, I call it the modern stick man diagram. Is what I spend a lot of time looking at in Cameo, because you see, they have the different models, and it's like, oh, this is a block, and there's a line going to the block, and there's a triangle, and there's a circle, and it's like, oh, okay. And I grew up in a world where we had, block diagrams, and nozzles look like nozzles, and boxes like boxes. But it's now to a point where I'm like, hey, don't worry about the tool, worry about your audience, worry about yourself and getting that understanding. Create the models and set them up in such a way that when you start to do this digital transformation, yes, to your point, Lee, you're getting in that data, but you're using it to understand it and make sense. It's useless to create a tool or to get a tool to start putting things to it and integrating it if you don't understand what you're looking at. So I'm always about, it needs to be understandable, it needs to be something you can use.
Awesome, I love it. What about you, Anna? Any best practices you would recommend to fellow thought leaders?
Well, my big takeaway is simulation is not a digital twin, so don't get confused. And if you're thinking it's confusing, go read about it. Or come talk to me and I'll send you some papers over. But that's what I've been trying to clarify in my academia world. And every time I meet with people and I talk about it, it is not, and it's confusing because they share the same capabilities, but it is not the same thing. So I think that's my big
Great.
take-home exercise.
Well taken.
I think my message would be embrace change. And, obviously, new tools, new techniques. Again, a diagram is a diagram, right? But the new capability is now take that diagram and actually simulate not only the performance, simulate the behavior. You can now understand how that system would react to an off-nominal condition. And the second part of that is what I mentioned earlier is I would really implore both government and industry to come together on this. So how can the government, change their RFPs and their contracts to encourage and incentivize digital transformation, model-based techniques, more efficient ways of doing things, and then how can industry come forward and offer up, hey, if we can do this way. I think specifically the use of digital twins to really compress the amount of time and money we spend in testing. And I would offer up, Anna, and I think your research probably shows this, it's a model of a physical thing, but one of the also very powerful aspects of a digital twin is I can also then lay on the software on top of that. And I can now get a much better feel for how that integrated hardware-software system would perform, would behave, would react, and start to run some of those trades between hardware and software, which ultimately could save time, could save money downstream. So.
I'm going to cheat and say two things. The first is, we talk about digital transformation, the importance of that cultural shift. Leaders have to get behind this, if for no other reason than that you're dealing with a workforce that's arriving as digital natives. Anna talked about training. In some ways, they're training us, right? They're all coming at this from a world of expectation about things that are linked together and the accessibility of data in their daily lives. So, when we stand up and say, sorry, you can't connect those systems, it doesn't all work together, you can't model it, they scratch their heads and they say, why would I even want to work for an organization that can't do such fundamental stuff, right? So that's the first part. The second part is, I really encourage organizations to be ready for the impact that this generation of AI is going to have. Again, I've been in the field for a long time. There have been a lot of things to be skeptical about, but the current wave of generative AI really is going to change the way that humans do a lot of things. You all spend your days, we all spend our days sitting in front, typing on keyboards, mousing. This is going to look really silly to us 10 years from now. And we'll all look back on this time and say, wow, do you remember how much time we used to just spend pounding on keyboards? Why do we do this? Well, we do it because the only effective way we have to communicate with machines is via keyboards. But that is a very temporary situation. Software development is going to change fundamentally over the next, it's already changing. Literally, software developers I know are all moving to using generative AI as part of the way that they do their work. Digital design is going to be transformed. So I know it's easy to just sort of say, look, it's just a fad. There is way too much hype. Get it. But the hype cycle will pass really quickly, and actually the change it's going to drive is going to be very profound. So be ready. Strap in.
I love those emphasis points. And just piggybacking on your last point about coding with generative AI, as we get to trust generative AI coding models and as we get them through our security processes, all of us probably have a lot of codes that we would love to modernize. And some of the translation capability there has a lot of promise. It's not perfect yet, but there is probably a lot of potential for savings, or either time savings or money savings, leveraging generative AI to help us translate codes to new paradigms. So, do we have time for a couple of audience questions?
A little bit of time. So we've got the mic runners here. Why don't we go to
First of all, thank you very much. This is very interesting. Probably have about 20 questions, but I'll down to one. And it actually I'm the Vice President for Research at the UAH, and so obviously mine is in the area of workforce development. In essence, usually teaching starts from graduate school down, but this digital transformation is a little bit interesting in the sense that it might be able to teach engineering when they don't know the fundamentals ahead of time. And so my question is to Anna, or as well as to Virgil, what kind of input can you provide to universities to how to use this digital transformation to produce a better workforce?
Okay. So in our department, Industrial and Systems Engineering Department, we're going to offer a special topics class next semester for both undergraduate and graduate on digital engineering, where we're going to talk about generally all this digital transformation, engineering, digital twins, and let the students dig into, and I'm going to be teaching that class, but we're trying to figure out how to teach that because we don't know yet. So our try will be have a type of seminar class where we do research type of class, where we have students to dig into special topics related to the digital world, and present to students and share and talk and create this discussion to see what are the main outcomes that we get from that type of seminar class to be able to create a curriculum for the undergraduate, like for the basic undergraduate for everybody to have. And that's what in the industrial system is doing, but I don't know about the other departments, but I think it is a component to all the other engineers that we should have.
So I know we're running out of time, but I'll add real quickly. I've hired a lot of engineers over the last 6 or 7 years. They come in and they know the tools, but they don't know how to apply it. So I would say the biggest thing is I want somebody that when I bring in day one, they're effective, not just on using Cameo and other tools, but they can then say, oh, within school have applied this to X, Y, and Z problems, and I'm like, perfect, let's get to work.
Okay, really quickly. I manage several engineering teams at NASA Goddard Space Flight Center, and the emphasis is on Earth data infrastructure. So it's Earth observing systems and so forth. We've been really successful using the safe, agile approach, which is a scaled framework. And the reason I think that's been successful is because you're looking at stakeholders from the enterprise level, the business level, as well as your agile teams. So you can build and harden systems early on in the design phase. So my question, when I heard everyone talk with regard to the digital transformation, I thought of Space Policy Directive 5 with regard to open science and open architecture. To what extent are we considering SPD 5 with respect to the digital transformation?
I'll provide a few thoughts there, but it's an excellent point. So again, I think a lot of the safe agile processes, that, in my mind, I think of those primarily being used in a software context. It's how can we transition those to the broader design, right? So how can we get a Scrum type of approach in hardware and again, incremental design. The other thing is, there's been a tendency over the last couple decades to kind of decouple the hardware and software during the design and development phase. We'll kind of generate requirements, we'll partition them off, and then those teams will go forward and do their thing. And again, coming back to kind of a digital twin approach, really can always look at the integrated system throughout the, if you will, design development life cycle. And then being able to make those trade-offs back to what the mission needs, the mission requirements were. And I think is just something that we need to do more of going forward.
Were you saying one more? One more?
Very quick question with quick answers, please.
All right.
Sure. Is there potentially any reason for maybe the lack of integration or adoption of digital transformation due to the fact that there isn't a widely agreed upon definition or guideline for what digital transformation even is? It seems to be very company by company or even industry by industry for how digital transformation is taking place. Should there be a standardization process?
I can offer that the NASA digital transformation team has publicly published our digital transformation plan. I won't tell you that that's the magic blueprint for everybody, but it's kind of a logical documentation of how NASA's approaching it. That's out on NASA Technical Report Server, ntrs.nasa.gov. If you look up digital transformation in there, you'll see the way that we're approaching it, and happy to share scars, philosophies, or whatever. So I think we're at time. How about a hand for our great panel here?